right, ladies and gentlemen, how are you today?
Good.
Are you excited? Do you like the Discovery Center? Isn't it beautiful? Have you been out there playing with all kinds of things out there? All right, and today we're going to be talking about getting there. How many of you know where the moon is at? Do you see the moon at night? All right, well, this gentleman's going to tell you all about getting there and all kinds of exciting things about that. So after we have a presentation, then we have some activities, we have some puzzles and some colors, and he has some pretty cool rockets that we're going to make and see if we can launch them, all right? So have a good time today.
All right, good morning, everyone.
Good morning.
Oh, well, okay, now you sound like my freshman in my class. Good morning, everyone. Expect a little bit more excitement out of you guys. Okay, well, I'm a professor at Penn State, and sometimes I'm called a rocket scientist, okay? But don't let that scare you. And I'm going to be talking about how we might be able to get to the moon. Okay, so how many of you have heard that Penn State is working on a mission to get to the moon? Okay, what's it called?
The Lunar Lion.
Lunar Lions, that's right, okay? And so, I got to use this map over here. Okay, so we're going to be working on trying to get to the moon. And we're going to be launching, getting to the moon, and then making a hop in order to compete in a prize called the Google Lunar X Prize. And this is not an easy task, as you might imagine, right? Going to the moon is going to take a lot of effort to get there. Once we launch, we pretty much have to get to the moon with everything that we've started off the Earth with, right? Okay. There are some tricks we could play if we were clever engineers, etc. To do that, we could do some staging, like we could put a gas station in low Earth orbit, etc. To be able to get to the moon. But we're not going to be able to do that as part of our competition. What other kinds of things? What other challenges? Okay, everybody, all the kids, stand up. You got an idea? What do you think?
Running out of food.
Yeah, we could run out of food too. It's going to take a little bit of time to get there. And we'll talk about how far it is later on. But everybody stand up. Okay, stand up. All right. Now, I want you to do something. Jump. Well, how come you guys aren't still going up?
Is that you?
What?
Oh!
What happened?
Gravity.
Gravity. We have a big problem. That problem is gravity. Okay? Gravity is beneficial to us. You can sit down again if you want to. But we've got a big problem. We've got to get off of this Earth. And that's what takes, and the gravity keeps us attached. Like my feet are attached to the Earth, and I'm glad that they are. Okay? Because I've always said that I've never been very good with frictionless surfaces. So we've got problems of gravity. We've got to figure out how to deal with that. So, unfortunately, it is rocket science. Okay, but I don't want to scare you about that. All right, we're gonna simplify this a little bit. So, there was this dude. Okay, pretty smart guy. His name was Newton. Okay, like that fig Newton that you eat. Okay. And he came up with 3 laws that he said govern motion. The reason you don't move is because Newton said that, hey, objects that are at rest tend to stay at rest, and objects that are in motion tend to stay in motion. Okay? So in the absence of all other forces, objects at rest tend to stay at rest. That's his first law. So he has a second law, and this one's maybe more technical, but it's an important law. And he said that that basically force equals mass times acceleration, and we'll talk about that without using the equation over here. But it's simple and it's important. And the third law that he talked about, and this is the really important law for rocket scientists, okay, is that for every action there's an equal and opposite reaction. Okay? So, this is one of the reasons why when you're sitting in a chair, okay, the chair pushes up on you at the same amount of force that you're pushing down on the chair. If those two are not equal, okay, then the chair falls out from underneath it. Okay, but we use this same equation, or we use this same law when we're talking about rockets. So we'll come back to that here. Okay, so let's go back to this gravity thing. The issue with gravity, it's not just a good idea, it's the law. We have to deal with it. We have to figure out how to get ourselves out of Earth's gravity. So, we have a concept that we talk about, it's called gravity wells. Okay? How many of you have been to the beach and have dug a hole in the sand? Okay, have you done that? Okay, they've just outlawed this in Los Angeles. But have you all done that? Or dug a hole in your backyard or something? Okay. So the deeper you dig that hole, right? Is it easier or harder to get out of that hole?
Harder.
It's harder, right? So if I've got a very deep hole, it's hard for me to get out of that. If I've got a very shallow hole, I can very easily get out of it. This is similar to the situation between the Earth and the Moon when it comes to gravity. Okay? The Earth has what's called a gravity well. And it takes a certain amount of energy, because it's a very deep gravity well, to be able to get out of that. The Moon has a very shallow gravity well. And so it takes less amount of energy. This is why getting to the Moon takes a very, very big rocket. But getting back to the Moon can be done with a small rocket. Okay, now for Lunar Lions, we're not coming back from the Moon. We're just going to go there. Okay, it's a one-way trip. That's why we're not sending people. Okay, but this gravity well is very important. So we got to figure out, how deep is this well? Okay, because it's not like it's a physical hole that we can just look in and look down and see the bottom of that hole and figure out how far it is. So we got to figure this out. Okay, so one reason, again, why the hole is much bigger for the Earth than the Moon is because the Earth is much bigger than the Moon. But we're really talking about mass, actually. But the size of the Earth is much, much bigger than the Moon, so it's much more difficult. So this same dude, Newton, okay, who's a really smart guy, he also invented something called calculus, which will sort of vex you when you get to college. He invented this. He said, okay, let's have a thought experiment. Okay, this is something where he said we don't actually have to do this experiment. He couldn't do it in his day and age, but we can do it today. He said, let's think about this. And this is his picture. See, it was drawn way back in the 1600s. Okay, and 1700s, 1600s, in that era. And what he said is, let's go to the top of a very tall mountain, and we're going to fire a cannonball. Okay? So if all of you took a ball and threw it, okay? Throw a ball. You can throw that ball farther if you're standing on top of a mountain or a hill than you can when you're on the ground. But he said, let's try it. So here's his experiment. He said, okay, we're gonna put a cannon on the top of a mountain, and we're gonna fire a cannonball. Okay, and we're gonna start with, say, a certain speed that we fire that ball. So give me a number from, say, 1 to 5.
4.
4. Okay. So we're gonna put in 4 kilometers per second. We're gonna fire this ball. What do you think is going to happen?
It's going to go around the Earth.
It's going to go around the Earth. So it's going to go all the way around the Earth. Let's see. Oh, no sound. Oops. Didn't quite make it. Okay? Didn't quite make it around the Earth. Let's try a different number. What do you think? What do you think? 10. Okay. Let's try 10. Let's try a slightly bigger number, and then we'll try 10. So we'll try 7 first. Let's see what happens. Oh, it's going pretty far. Okay. But look at this. Here's something you can see. It's going faster, but now it's beginning to slow down. Okay. And the acceleration that's left is beginning to decrease.
No gravity.
No, I've got gravity. Still got gravity. That's what's affecting this. But let me clear this next. Okay. So there's first some velocity that I have to fire this, and I can put something into orbit. So when the space shuttle launches, it has to go above. It has to get to a certain speed so that it can orbit the Earth. Okay. But we need to get to a speed that's much faster. Otherwise, we're just going to continue to orbit the Earth. Okay? So we have to, in order to get out of this well, this gravity well, we've got to get to a certain speed in order to get to the moon. Okay? There we go. That's actually going to bonk us in the back here. Okay? So at some point, the ball goes from hitting the Earth, okay, to orbiting the Earth, to escaping the Earth. Okay? And all of that is governed by the speed at which I fire this ball. So we have to be going, how fast do you think? So it's more than 10, right? We put in 10, we tried 7. And that was getting there. You think it's bigger than 10? How do you think it's bigger than 10? 10 kilometers per second. Good boy. It's 11. It's actually 11.2 kilometers per second. That's how fast we need to be going to get to the moon. Okay? That's how fast we need to be going to reach what's called escape velocity. I mean, when you see a rocket start, right? When you see a rocket launch from the Earth, it's going very, very slowly. But eventually, by the time it gets to space, it's going very, very fast. Okay? All right. So this is what's called the escape velocity. And you got very close. So 11.2 kilometers per second is how far we need to go. All right, so the last thing we want to talk about is how does a rocket engine work? Okay, we said this uses Newton's third law. We also talked about one of the other problems getting to the moon is the distance. Okay, so it's about 239,000 miles to get to the moon. Well, that's just the distance between the centers of the moon and the Earth. That's an average distance and all that good stuff, but that's the distance. The thing is, what I want to leave you with is that getting to the moon is a challenge. But we know how to do it, and we can do it. And that's what we're going to be doing with the Google Lunar X Prize here with the Lunar Lions, okay? So, wish us luck, keep track of us, and we'll get there.